So this is going to be another video about the multiplicity of zeros, and in these example problems that we're going to be going over, we're basically going to be finding the linear factors for the polynomials and include their multiplicity in our answer. So let's get this first one going here. You'll notice first that there is a zero here at -3, and then there's a bounce. It's still a zero, but at -1, but it's a bounce off of it, and then it goes through right here at 1/2. Okay, so we want to figure out what would cause a zero for each of these if it was a linear factor. Okay, so that first one where it's a zero at x is equal to -3, the linear factor for this one would just be x plus 3. Okay, so that's one of the linear factors for this polynomial. Now, since it goes right through it and it doesn't curve or anything like that, it doesn't bounce, it is going to have a multiplicity of 1. So I'm just going to write m1 on this, multiplicity of 1. Okay, this next one, this -1 right here, at x equals -1, there is a bounce, meaning it doesn't actually cross through the x-axis, and since there is a bounce, that means it's going to be an even power for that. I'm just going to assume that it's a 2 here, as long as you assume the lowest one, that's pretty much a safe bet. So then this one would be technically x plus 1 quantity squared because of that bounce. So because of that, this would have a multiplicity of 2. So x equals 1 would have a multiplicity of 2, essentially, because of that bounce. And this last one right here, where it goes through x is equal to 1/2, because it's going right through it, it's going to have a multiplicity of 1. So I'm going to write that down right away. I'm going to write multiplicity of 1. Okay, and what this is going to represent for a linear function, you could do x is x minus 1/2, but you could also do this where it's like 2x minus 1, because if you actually tried to solve this, setting it equal to 0, or you put 1/2 in there, you would still get a 0 on that. So the possible linear factors would be x plus 3, x plus 1. It would be squared though, so it would have a multiplicity of 2, again, because of that bounce there, and then 2x minus 1 because it goes right through it. Okay, so that's going to be our answers for all of these. All right, moving on to number 7 here. All right, first thing I want you to notice is there is a bounce here. So at x equals 3, it's probably going to have it's definitely going to have a multiplicity of at least 2. This one at x equals 0, this one goes right through it, so we don't have to worry about the multiplicity there. And then this one right here at -3.5 is also going to go right through, so it's just going to have a multiplicity of 1. So this would have a multiplicity of 1, this would have a multiplicity of 1. Now to make it as linear factors again, so let's just start with that x equals 3. What you need to do is just turn this into a linear factor, turn this into a linear expression that if you plugged in 3, you would get 0. So x minus 3, if you plugged in 3, you'd get 0. And it bounces off that, so you could say that it's a multiplicity of at least 2 on that one. Okay. The next one, let's just go x equals 0. Now, as a linear expression for this one, it would just be x. So you could set x equal to 0 and solve. X would be 0 for that one. And it goes right through it, so we're going to say multiplicity of 1. And that last one at x is equal to -3.5. One way you can do it is if you did something like 2x plus 7. Okay, if you plugged -3.5 in here, you would get 0 on this. And it goes right through it, so it would be multiplicity of 1. For that. Okay, so those are some possible answers for that one. Okay. Let's go on to number 8. Okay, got a couple bounces on this one. All right, so at x equals -2.5, it goes right through it, so that's probably going to be a multiplicity of 1 then. Right here we have a bounce, so that'll probably be a multiplicity of 2, and then here we also have another bounce, so let's just assume multiplicity of 2. The main thing, you can't really know if it's a 2 or a 4 or a 6, but as long as you know it's even, that's fine. We're usually just going to use the lowest possible multiplicity that it can have, so that's why I'm writing 2 in there. All right, let's start with, let's see here. X is equal to -2.5. Okay, now we need a linear expression that could express that. So it's going to be 2x plus 5. So if I put the negative 2.5 in for x here, it would be equal to 0. Another way you can think about it is if you did like 2x plus 5 is equal to 0. You subtract the 5 to the other side, so you have 2x is equal to negative 5, and then you divide both sides by 2, and you'll get negative 5 over 2, which is equal to the negative 2.5. So that's where that 2x plus 5 is coming from. And since it goes right through it, it's going to be a multiplicity of 1. Okay. Let's see here. I'm going to put some lines here to separate this off. All right, so the next one is x equals negative 1. Now there is a bounce, so that bounce tells us that, again, it's going to have a multiplicity of 2. I'm going to put an x plus 1 for the linear factor, and I'll write multiplicity of 2 for that one. And the last one, there's a bounce at x equals 3. So it's going to be x minus 3, because if you plugged in 3, you'd get 0 here. And that's a bounce, so we're going to say multiplicity of 2 for that one. So that's those right here. Okay. All right, this next one here. So I'm going to locate all the zeros first. This one, there's a bounce on this one. So we're going to say multiplicity 2. This one, it goes through it. It crosses the x-axis, but it also kind of curves a little bit. So it's not going to be multiplicity 1 because it would just kind of go straight through it if you had that. So let's just say it's a multiplicity of 3. It's definitely going to be odd, and it can't be 1. So the next closest odd number would be 3. So that's why I'm going to put a 3 in there. Okay. All right. From here, I'm going to write x is equal to negative 2. And there is a bounce on that. So it's going to be x plus 2. And it's got a multiplicity of 2. So I'm going to put a squared in there. And it's got a multiplicity of 2. Okay. I probably should have done that for some of these other ones too. Like I could have put a squared here. I could have put a squared here because of the multiplicity. Didn't do it on this one either here. So squared. And that one does have a squared. Now, it is important to kind of get some context on what we're doing here. So that this first one, number 6, that polynomial p, another way of looking at it, so it's polynomial p right here. Another way of looking at it is you can say p of x is equal to x plus 3 times x plus 1 quantity squared times 2x minus 1. Okay, now if you notice the amount of turns there's 1, 2, 3 turns on this. So that means this should have a power of x to the 4th. So if you notice that we have 1x here, 2 x's here, and another x here. So that would make it so it does have a power of 4. Okay, now this is a possible, what I'm highlighting right here, this is a possible equation function for p, but there are little nuances that you can have too, like maybe it's times 1, like 1.5 or times 2 or something like that. But for the most part, those are at least the linear factors for p of x. So that's essentially what we're finding when we're finding all these linear factors. We're finding a possible, equation that's going to explain what p of x is doing. And you can do the same thing on this one here. Okay, this one's also x to the 4th because there's 3 turns here. So you can say that it's p of x is equal to, x minus 3 squared times x times 2x plus 7. Okay, and there's 4 x's in this because there's 2 here, 1 here, and 1 here. So that would be 4. So it still does follow the x to the 4th power on that one. This one, same thing, only this time there's 1, 2, 3, 4 turns. So this would be an x to the 5th. It does go forward up here too as well, so that means it does have a positive leading coefficient. The other ones do as well. Okay, just trying to give you some context on what we're trying to solve for here. All right, this next one here, so x equals negative 2, and then there's another one at x equals 0. Okay, so that's just going to be x for the linear factor of that one, and we're going to say that it's a multiplicity of 3. Because this is a multiplicity of 3, you can actually put a little 3 in there as well. The linear factors are x, but there's 3 of them. So if you were trying to make the p of x like function for this using these linear factors, it could be something like this, where it's x plus 2 squared times x to the third. And this last one here, it says, is the multiplicity of 0 at x equals 6 even or odd? Okay, well here's x equals 6 right here, and it crosses through it, so that tells you right away that it's odd. Anytime it crosses through it, it's going to be odd. Okay, anytime it bounces, like at -4, x equals -4, that's going to be even. Okay, but for this one, it is going to be an odd multiplicity on that. Okay, this one would be even. All right, so that's 5 example problems involving the multiplicity of zeros. If you have any questions about anything in this video, let me know.